Okay, I'm back, and so we're just about finished talking about weather and climate, but we want to, I just wanted to tie it all together and say, how does this produce global wind systems? So we said in our previous segment that up in the stratosphere, that the winds blow to the north, and then the surface winds blow to the south. So up here at the troposphere stratosphere boundary, the winds are trying to go north, but then when they get up to here, they have to fall back down at 30 degrees latitude, and then they start to go back to the equator, so they're heading south. So in that first picture that you see over there to the left, you'll see it's got those red arrows, and those red arrows represent surface winds. So that between 30 and 0 degrees latitude, the winds are trying to go south, but they're being bent in this direction because of the Coriolis effect. So these are going to be called the trade winds. So the trade winds are going to blow from north to southwest. Okay, then in this region up here, now we're going to have the air is coming down and then it's going north. So the surface winds are trying to go north, but they are going to be bent to the right like that. And so those are going to be called the westerlies. They're called the westerlies because they're coming from the west. So the west is over here, and so these winds are blowing from the west to the northeast, and they're going to blow like that. And then let's not worry about what's going on up here. So if you look at the picture there that's on the right, then that's going to show the global wind systems. And what you should notice is that you've got arrows that are going up and then bending to the right, and then you've got arrows that are going south and then they're bending to the left. And so that is because of the Coriolis effect. And then later we're going to find out that those winds, as they blow across the surface of the ocean, are going to cause the ocean to move. And so there are ocean currents that are going to be caused by the wind systems. Now, what's going on in between the convection cells? So we said that there was a convection cell here, and then you had a convection cell that was over here. So what's going on right there in between where those two convection cells are coming together? Well, that's going to be very turbulent, and that's going to be where the jet streams are. So you're going to have a jet stream that's going to be located right here, and then you've got another convection cell that's up here. So it's going up and then over, and then it's coming down. And so right in between those two convection cells is going to be another jet stream. So that here in Missouri, we're more interested with this polar jet stream that's up here. So that's the one that carries a lot of high and low pressure systems and weather systems into the Ozarks. On the other hand, if you live in California, you're going to be more interested in this jet stream down here, which corresponds to this one, and that's going to be the subtropical jet stream, and that one is going to bring in weather into California. So remember, United States is in between these two jet streams, so we get affected by both of them. Okay, but notice how fast these jet streams run. So they have speeds of between 129 and 225 kilometers per hour. But they can get up to speeds of 200 or 443 kilometers per hour. So they can be very, very high. We first noticed these things during World War II. So when the United States was fighting World War II and we had to bomb the Japanese, we were sending our bombers across the Pacific in order to get to Japan. But what we found was we were running into a headwind when we would do that. And then when they were returning from their bombing run, all of a sudden they had this tailwind. And so that wind was caused by the jet streams. All right, let's take a break, and when we come back, we're going to talk about the hydrological cycle.